So yeah, I was having idea to start a bit with the spec, just to explain to everyone like the basic idea, so we are kind of on the same we have a common ground, and then to discuss a bit the PR and tests and the way how currently it looks like making the changes to the consensus. So idea is not to necessarily discuss why something is done like this, or because it's a bit kind of tricky maybe to do it online, but it's more idea to understand when we make a change right now to the core consensus algorithm, how it looks like to modify it in the code, and also then with respect to the ADR on consensus refactor, how this might look like in a new version. So this is basically the yeah. So where is the share screen button?
Should be right at the bottom next to like participants and chat.
Mm-hmm. Okay. Yeah. So basically so as I just explained, we'll go a little bit over the spec, and then we'll show maybe on a few examples how this look like when we want to make some changes there. So I haven't yet finished also the more complex PR. So we'll kind of discuss the preliminary changes there, and more idea. My idea is to more discuss in general like how it looks like right now to do those changes, and then how it looks like to validate them, because this is the tricky part, as you will see. So in general, so in Tendermint consensus, we need, because the topic is basically termination. And so for termination, there are a few requirements which need to hold. The first one is that we need to have timely and reliable communication between all correct processes. And so this is very important because right now we have few issues where we basically, upon receiving 2/3 of pre-vote or pre-commit messages, we are jumping ahead without waiting enough. So we don't actually ensure that we got messages from all correct processes. So this is very important, because if we have a faulty processes like Byzantine faulty one, which are sending us nil or some correct messages, and we don't wait for correct one, we can't ensure that we'll terminate in that instance. So this is the first requirement. And the second one is the way how we ensure that eventually in a round we'll really be able to reach agreement. So all correct guy will pre-vote and pre-commit for a same value. So without going too much into detail there, idea is that proposal message eventually in some round need to be accepted by all correct processes. And we are ensuring this by using valid value and valid round variables. In the code, they are called valid block or valid round or valid block round, something like this. So there are similar concepts. And so idea here is that with this valid value and valid round, they actually represent the possible decision value. So if in some round we are able to make decision on some value, and the precondition for this is locking a value, particular value, then valid value and valid round should be that value, basically. And so you also one thing, like more on a formal side, we are assuming partially synchronous system model, which means that eventually, where we don't know when this eventually will happen, we'll have timely and reliable communication between all correct processes. And so in that case, if a correct process locked a value, we ensure with the algorithm that all correct processes will update valid value and valid round to that particularly locked value. And this is, if you want, a point of more or less reaching kind of the same value. And in consensus, this is sometimes also called like going from multivalent to univalent configuration. So after that point, this is the only value which can be decided, and this is also how we ensure termination. So I know that this is maybe a bit maybe going a bit too technical here, but somehow what we should kind of take away from this is that we need to have this synchronous communication between all correct processes, and they need to eventually update valid value in some round to the same value. If we manage to do this, then in the following rounds we'll really ensure termination. Do you have maybe a question regarding this part? All good. Okay, cool. Now, one of the issues we were having was basically the fact that so it's that we haven't been, like, if you look at the spec, when we move to the next round, we need to wait a timeout pre-commit. And so this is something which is needed because of the ensuring property that valid value and valid round will be updated to the same value. And so if we leave round too early, then we don't ensure this and we can't guarantee termination. And in the current version, when we were receiving 2f+1 pre-commit for nil value, we were moving ahead without waiting for a timeout. And so basically in this pull request, we were changing this. So here it's relatively straightforward to modify at a consensus level. So instead of, so when length of block ID hash is 0, this actually means that we are pre-committing nil. So in the current version of the code, when we have a 2/3 majority for nil, then we were immediately entering new round and validating this valid value, valid log property. So in the new version, basically it's just it's a slightly modified version of it, so there is nothing special there. Now the question is how we test that this modification indeed holds, like, and that we are not breaking some other properties. This is somehow the kind of the major question. And so how we so how we found issue. So we found issue by inspecting inspecting code with respect to the spec. So right now we don't have, I would say we don't have enough tests which would be, let's say, covering all interesting cases with respect to termination. So it's right now, it was up to now, it was quite manual. So we were looking at the algorithm and we were writing proofs. So we are convinced that indeed we are able to enforce what we want there. And then after we stabilized on the spec, we were inspecting code and seeing where there are basically misalignment and creating issues there. And so now we are in the process of fixing it. And I hope also improving tests so we are able to catch these kind of issues in the future. And so right now so most of the consensus related code sits in consensus state.go file, and this is state. So do you see is font big enough or? Okay. So these are the tests which are kind of core consensus related. And this is how we are testing some of those core related stuff right now. And so typically what we need to do, we need to set up a set of validators, or actually their consensus state. And then we need to really kind of start the consensus engine. So we are effectively starting routines which are dealing with some messages or events. And then we are going through some particular scenario, which is kind of quite detailed right now. So maybe I don't know who is most like convenient with this test to maybe give us a bit of intuition. What was the idea behind or how it works? So I can tell my version, but maybe Bucky has a better view on it.
Sure, I can just point out like what the comments mean here, just so everyone is clear. So in this case, we have 4 validators, and really the only state machine we're actually running is for the first guy, the CS1, and the others are just like kind of mocks. They're just shells of validators, just so they produce signatures, but they don't actually execute consensus state. So we get to determine what messages CS1 receives from all the others. And so down in this comment here, where I'm saying round 1, CS1 is the proposer and proposes the block B. And then everyone pre-votes for B. So that's what the following. So these double slashes kind of separate the proposal from the pre-votes from the pre-commits. It's just kind of a shorthand notation for trying to describe what happened in this round. So in this first round, CS1 proposes a block B, and everyone sees the block and pre-votes for that block. But then when it's come time to pre-commit, 2 of them pre-commit for B and the others pre-commit for nil. And that's simulating as if they didn't see the 2/3 pre-votes, so they just pre-committed nil because there wasn't justification for them to pre-commit B. And so in that situation, we should be moving on to the next round. But CS1 and the third, the VS3, should be locked on the block in the new round. So then, the code actually walks through all of that happening using a bunch of convenience functions. So first you see, we wait to receive the proposal off the proposal channel. So all of this is using the kind of internal consensus event system. So it receives the proposal, checks the hash, ensures that it receives a vote from itself, because the consensus state machine is kind of autonomous. It'll, if you're the proposer, you'll also produce the first pre-vote. And then it sees, and then this sign add vote function actually goes and signs the votes from everyone. So you can see all the signers at the end there, VS2, VS3, VS4, and they're all for the same value. And then again, the consensus state is autonomously sending the pre-commit. So we're ensuring that we see the pre-commit from the active consensus state. And then we're validating that all the values are what we thought they were. And then then finally we add the pre-commits from all the others. And here we distinguish that validators 2 and 4 are actually sending us nil, while the final validator 3, is signing a pre-commit for the block. And then, so not from there, we should time out into the new round. It'll be a new proposer proposing a block, but we basically take advantage right then to actually set the proposal block to what we want it to be before we then increment the round and move into the next round. So this is simulating a round passing the way we wanted it to in terms of the messages that consensus state 1 receives from everyone else.
Yeah, so in general, with this kind of setup, we can do quite sophisticated scenarios. It's just that they are quite long to write. And so the issues I was having when I was modifying the algorithm, because some tests were failing, of course. So the good thing is that tests are failing, so we are able to catch the changes. The bad thing is that they are not pointing out where we fail, because we have a bunch of those reads from the internal channels, and if they're not surrounded by the timeout, and so in the PR, basically, I added a couple of tests with this kind of ensure pattern, test of functions, which are just more or less having the same pattern. So we are just wrapping it up with a timer so that we can point out to the more or less to the line where we fail. So if before we were panicking in this case, and then Alex suggested that it's more clean in this case to log that there is actually error, and we can point out the more kind of readable the error message. And so this is something I think which is so it helps, because now if when you change the algorithm, at least couple of those simpler cases will be able to if the algorithm is stuck now on one of those cases, then you will able to see where it's stuck. I haven't fixed yet the stuff where we are really reading a value from a channel, because this is something where it was not really clear for me, like what is the type and can you really ensure something kind of clean there, so that when we also wait for something on a channel, we can cast it to a proper type, and then we can do a more meaningful check there, and then replace it also, add sort of waiting on a timeout instead of just doing something like this, because this will hang if there is no proposal on a proposal channel. So this is something which so I did a bit of work here. I haven't completely cleaned it, but just wanted to have a kind of quick feedback from you guys. What do you think about this, or would you prefer that we do it something different? Because the
comment here.
Mhm.
There was at some point a PR that changed or added a function. I forget. I think it was ensure new round. It might be something different. Maybe it was ensure new step or some other function. It looks like this line number 633 here, except you also have to pass in the actual round number that you were expecting or something of that nature. So you pass in the number, the height in the round, maybe the step. And that helped me a lot, because what happens is all of these ensure things, ensure vote. Oh yeah, the ensure vote. Maybe that's what I did.
Yeah.
Yeah, with
So
the height and round number. So
yeah,
I think
so this is basically what you did in a PR, and so I pulled in it here, and I was kind of using the same pattern, but for a simpler cases, so that we always wrap reading from a channel by a timer, and then here you're also casting it to a proper type, and then you are able to do a really kind of semantic check here.
right. So
So I think that idea is to more or less do this for all reads from the channel, where we'll cast it to a proper type. So Anton point out today, because I was not able to create a link between an event type and the data type, which really is sent on the event bus. And so Anton explained how it works. So I think we can always do these things. So we know for each channel basically what we can expect there. So we can do this kind of pattern, I think, for every So the only change here is that instead of panicking when there is error, we just log basically that the error message. But it's exactly the same. It's what you did. I just try to follow up exactly the same pattern. This is really very helpful.
Just curious, why does it help to print the error instead of panicking? Wouldn't it be better to know exactly that something like I don't know. This is maybe a question of debugging preferences, but is there an issue if we stop the logic as soon as there's one problem?
I guess that maybe Alex, you can provide a bit input here, but I guess idea is that we don't print stack trace, but we just print a particular error message.
Right. So I think actually a panic might show more information because as long as we print the error, maybe we can print and then panic. But panicking tells us which ensure vote function failed. But if we just print it out, it becomes more difficult to figure out exactly which line it's talking about. Ah, when it's error. But I mean, it would tell you which line inside the implementation of ensure vote, but would it also show you like line 638? Because you would need the stack trace to know that. But we're not doing that here with ensure vote. So
Yeah. Yeah. So here the basically the one option would be to return error, but then it would make reading the test kind of a bit harder because we are kind of here trying to build sort of DSL for reading what happened. And so what I personally don't like with the current test is that we want, for example, to test something which is kind of quite precise. So we have 4 validators, we have 1 pre-commit and other 3 polka at next round. So we unlock and pre-commit the polka. So we have a quite clear scenario. And then ideally we would be able to create a consensus state and then set it in a particular state and then just input the messages and check the output. So we don't need to go through all, because for this particular scenario we don't necessarily want to check that it indeed send I don't know, message or that some timeout expired or something like this, because it makes the test quite hard to understand what's going on. So right now my feeling is that making a change to the code is let's say it takes some time, and then fixing the test and understanding test is much more time consuming. So I'm wondering if there is a way to improve there to make it really more be to the point. And but we can maybe discuss this a bit later when we discuss this new refactoring idea. So I just want to point out something else. So also the way how I was kind of reasoning about the code. So the other issue we were having, they were related to the fact that we were moving ahead too early. So in the spec, and this is again, it's kind of a correctness issue, we need to wait for a proposal message or proposed timeout to expire before we send pre-vote message. And also, we don't want to send pre-commit message before pre-vote timeout expires. So we don't want on a first 2f+1 pre-votes to go immediately and sending pre-commit, because this there is a termination issue in this case. And so now what I'm currently working on is trying to modify the code so that we don't have such changes. And the way how I was kind of doing the check whether everything is fine, because we are right now. Let me just try to show basically a few things. So, for example, enter pre-vote is a function in which we are sort of sending pre-vote message. So when you call enter pre-vote message, at the end will really, based on the current state, send a pre-vote message. So then the critical thing is then when we are calling pre-vote, because when you call pre-vote, it's sort of it just do something, based on the current state. So what is more critical is when we'll call enter pre-vote. And you can see here that we do have some sort of comment when we are entering pre-vote. And so right now, basically, when you modify something, then you need to check really like where we are calling the thing, and then inspect the code to see like if we are covering all cases. So for example, here, this is the version where I already modified the thing, so we shouldn't be pre-voting if we either timeout propose expire or we already received complete proposal message. So you can see here that this is, for example, fine because we are in round set propose message and we have a complete propose. So then it's safe to move on to pre-vote. Then also if timeout propose expire, then it's also fine that to enter pre-vote, because in this case, if we are still waiting, then we can go ahead and pre-vote either. Right now we are pre-voting locked value. And the last thing is, and the most tricky one is when we receive a pre-vote message, then we need to check kind of whether the message is from a higher round or whether it's from the current round or from the previous one in the context of proof of locking value. And then that we are kind of doing the right thing. So I will not go here again into details why this is correct. It's just I just wanted to point out here that for me the fact that we are sort of making these comments for this kind of enter pre-vote, enter pre-commit, enter propose is potentially a sign that there is kind of possibility to improve this. And I again think that with the proposal for refactoring, we might be able to split and separate concern in a bit better way, so that we don't need to kind of do this kind of reasoning, that we can do more local reasoning. So when based on the current state and then input which are important, which we can see here, for example. So if initially, if we got a proposal message and proposal message is having -1 in a proof of locking field, and it's proposal for some value v, and we are in a proposed step, we can immediately act upon it and broadcast a pre-vote message. The other option is where valid round, proof of locking valid round is greater than -1. Then we need a proof that this is indeed was really locked value. So we need 12+1 pre-votes, and then we can do pre-vote. So if you look at these two kind of cases, they're at a different level of abstraction, I would say. So to be able to make this kind of reasoning in the code, which is really critical for the correctness, we need to have input which is kind of much more high level. So we need to know if we got a proposal for some block. We don't necessarily need to have those blocks, because you just need to know, okay, there is a block with block ID and we know this thing, we receive it. It is kind of complete. So we got both proposal message, proposal block, and pre-votes. And then, and that's it. And so by having this input, you can do some logic and then decide what you would pre-vote, whether it's a nil or V. And similar way, for example, if you talk about locking a value, so this case, then it's a similar thing. Like, do we have a proposal and do we have two F+1 pre-votes for a matching block ID? Then on this event, depending on our current state, we'll do some logic. And so what I think it would be really nice if in a code we are able to have we are able to reason at this level of abstraction, because this would make reasoning and writing tests hopefully much simpler. So so I don't know if you're able to follow me here, and so what is in general your idea on this?
One is that currently the code, I believe we pre-vote. We can pre-vote for a block without having received the whole block, right? Do we know that? So like, as long as we receive the proposal, I believe we are allowed to pre-vote for it, but we can't pre-commit until we have the full block.
So in a current version, you can pre-vote for your locked value. So in a sense, you don't need to receive proposal. You can pre-vote for something which is not nil without receiving proposal. Because if it's a locked value, then you can pre-vote for it.
Yeah, but if it's locked, I believe we can do that too. Let's see. Yeah, so even if we don't have the full proposal block, so I'm looking at line 1622, maybe. Oops.
Yeah, I modified a bit. This is not the last version, so we are probably not looking at the same thing. But
oh, actually, never mind. Looks like we only do it when the proposal is complete. Okay, never mind.
Yeah. So more or less, like the point here is that we could of course do this in any version. It's just that right now we have a lot of logic inside this add vote, which are sort of how to say, they're maybe at a different level of abstraction. And so if you look at what is the proposal regarding in this consensus refactor, so maybe, I don't know, Alex, do you want to explain the idea? But the way how I did it, yeah, you can maybe explain it and then you come in. Yeah, you can share your screen if you want. Yeah, so like if you look at the paper, more or less it is really quite closely corresponds to it. So we can think about this as some sort of DSL for distributed algorithms, where we have a way to input to what is, I think, here called now consensus executor or consensus state. I don't remember. Yeah, this is probably like let's say this consensus core thing, which calls the state which is similar to what we have in the paper. So just height round step and then locked value and valid value. And then it reacts on event. And so if we talk, for example, about these changes we need to make now, this would probably give us better way to test those cases in isolation without setting up the these more kind of complex thing, and without needing to drive the consensus state, what is now consensus state service through those states. So, for example, if you want to wait to see what happens when we have 2f plus 1 pre-commit nil, like do we wait for timeout or not, then ideally we can just write a test where we have a current consensus state and we input the messages, or we input those kind of more high-level event, and we see what is the next state, and other some output messages there. Because the problem with this core logic is that it's not a lot of code, but like one wrong condition or one wrong line, and the implementation is not correct anymore. And so this might never appear in production, but if it appeared, then it could be quite bad. So I think that it would be really nice if regarding those really core logic, we have a way to extensively test it, and if we have a way to have it as close as possible to the paper, so we could benefit from sort of proofs and reasoning there, and it's more clear what is happening there. And yeah. And so Jay and Anton were having the concern regarding the potential kind of performance decrease if we split things like this. And so I think that the proposal do not constrain us there. So like we can implement it, of course, in a different way. But in general, what this core logic really cares about is it's only block ID, and then whether we have those kind of high level event, like do we have for example, 2/3 of pre-commit for block ID, or because in general the core consensus logic is agreeing only on a block ID. So this is something which is kind of interesting to observe. So there are some details which do not appear in a spec, and it's not surprising. For example, the way how we send proposal block, we do it through a proposal message and block part messages, and then this is a kind of implementation detail, which makes sense in a context where Tendermint is supposed to be used. So we are doing the Swift based dissemination of the proposal block, but from the consensus core point of view, it's not so important. So you care only at the point where you receive a complete proposal block, and if you saw in a code what I was showing, then we have this is proposal block complete or something like this, which is basically then triggering some changes. And so the consensus reactor executor could basically do still those logic, and then only when there are some important events being observed, it can inform the core consensus state. And so also keeping all votes, checking signatures, because the core consensus logic also do not necessarily care about signature. So signatures can be checked before, and then we just need to know whether some guy voted for some V or V prime or nil. But then we can do, for example, the signature check also before in advance. So I think that it's quite promising, the approach, and if we do it properly, I hope we'll not see the performance decrease there. Maybe even like if we benefit from, for example, trying to somehow do the signature check in advance, maybe in parallel, it might even have maybe speed improvement. Because right now we, for example, do the signature verification in this kind of consensus routine. So it's really on a critical path, and so everything else is blocked while we are doing this, because we are keeping a lock on everything. So yeah, this is just one kind of potentially positive idea of separation from performance point of view. Mhm.
So yeah, so right, right, right. So Zarko responded. I just read it. Um, and the point is that we don't have to keep those complex vote sets and block part sets in the state, because I think the argument is that events about those states can be passed in to the consensus function. But I'm not sure. So I think I understand that from a high level, roughly how it does address the problem. So the point is we separate out those states out of state, and instead mutation events that are interesting are passed into the state, passed into the consensus function along with the state. But I'm not convinced that um, we can really separate out the timeout requirements from the state, and whether that would be a good thing. So like here in the consensus function, just below, if you scroll down a bit, um, it takes in as input event and state, and then output state and message. Um, uh, do we really want to separate out the decisions about when to enter pre-commit wait, for example? So the notion there is that um, something happened, namely we received a vote, and then it was, for example, sufficiently, we received more than 2/3 any of pre-votes, for example. And so now we have to start a timeout uh, to um, to wait the pre-commit wait period before we potentially move on to the next step. And sorry, I'm getting my terms confused. So if we receive 2/3 any of pre-votes, then we need to begin waiting the pre-vote wait period, so that even in the case where we don't receive a 2/3 majority of pre-votes, we move on and we pre-commit. Um, so I imagine we would want to test that somehow, that the state machine is correctly um, um, transitioning, and maybe returning a message saying, start waiting. But but this proposal doesn't do that. So I
Yeah.
wonder if that's what we want to do.
Well, the question is when, like, who is responsible for triggering timeouts? I think this is quite a good point, actually, because from the conceptual point of view, this should be part of the consensus function, because consensus function, depending on the events it get and the current state, decides, if timeout should be triggered or not. So from that point of view, yeah, this is somehow missing, and it's not really obvious. Like, we can trigger as a kind of side effect timeout, and then it will be reflected in a state. Yeah,
I think we may want to include the possibility of a return message being a timeout initiator. So instead of it being a message that you're going to send to your peers, it's like a timeout that you're going to start, or something like that. What I don't think we want is for the consensus function to like spawn an independent Go routine that's going to tick back into the thing, because we want to be able to control when that happens through the input. So either it could happen in the return function, or whatever in the return values, or whatever is calling that consensus has to inspect the return value and decide, oh, this change just happened, so we need to start a timeout. But it'd be good if it was explicit in, say, the message returned.
Right.
I think this should be fine, because then basically, like, similarly, like, you need to send a message, you will need to trigger a timeout, and also to wait on the when this timeout expired, to catch it and then potentially deliver it again to the consensus if needed. So yeah, this would probably be a nice way of dealing with this. And yeah, also one thing which I think could be kind of potentially performance issue is if when we do all those logic of passing the votes around and then checking the signature and everything, we could have issue there if we would be sharing this thing between the consensus function and executor. But if consensus just tell you we committed on this block ID, then executor can optimize, getting the block or getting a value, and then checking signature, and then executing it against the application. So, I think potentially we also have there to make a nice split that we are not affected in a negative way by this split. So.
Mm-hmm.
What? I don't. So okay. I think before we get to that argument, I think it's important to maybe focus on the first part, which is the overall shape of this consensus function, because I think that determines what I would want to, the way I would want to talk about the second part, which is the pureness versus impureness.
Mm-hmm.
So I don't understand. Yeah, I mean, right. So I think we agreed maybe what we want to do is have like some kind of message return type from the consensus function that tells the executor start waiting. But then, so I think that makes sense to me. So there's an event. The event is there was a new vote. So then the return is we update the
The event wouldn't be a new vote. The event would be like a 2/3 pre-vote any.
Exactly.
uh,
Like it is in the paper.
Right.
right. Um,
And so this event will probably have a height round, and that's it.
Right.
So
It wouldn't right. It wouldn't be an integer as it is now. It would be a structure, right? Is that right?
Yeah.
Right. Okay. Um, okay. Could do that, sure. Then, I mean, is that really the best way to do it? It seems like I see because the papers were in that way. Um,
I mean, it's not like we can also kind of write paper in a different way. It's just that in a paper I was trying to stay at as kind of high level as possible. So otherwise it gets quite long, and so then it's hard to reason about it. And if it goes kind of beyond one page, then it's hard to reason about it, and it's also like writing proofs and everything is a bit hard. And so maybe having those kind of important events which are leading to the change of the state are probably the most concise way of doing it. Because if you get a single vote, then this event is it's kind of too low level to reason it.
so
So
okay, in that case, what is message votes here really doing? What does it signify? Why do we ever want to return message votes? What does it mean?
That's the vote we're sending.
Ah, I see.
It says that now it's time for us to sign a vote. So here's the information, and then something that has access to our key will take that and sign a vote and send it off to the peers.
Okay, so, um, hmm. And decision. What are the decisions that we have?
Committed.
I see. I see.
and so this is typically just a block ID, because then or like something from which you can determine what is the block on which we have a commit. But it's not the complete block, so I don't think that block should ever go inside a consensus function.
If the message, that is message start timeout or something like that. Hmm. So, I guess, are we sure that there's no need to return multiple messages? That only one? Hmm. Why is that? I'm no longer sure. I'm not sure if we ever need to return more than one message at a time. So, what if message proposal means that this is a proposal we want to push out? Then I don't. Yeah, I don't know. Good question. I don't know if we ever need to also start a timeout. Um, it's not. Well, so I guess the question is every time it is time for us to broadcast a proposal because I'm the proposing validator, say. When do we do that? We do that after commit timeout, um, and that's the only time, as far as I know. So in that case, we wouldn't need to return any other message besides message proposal. So, like, in other words, when a message proposal is being returned, I don't think we would ever need to return any other kind of message.
Yeah, I think I mean, look at the spec. The spec also is, I think it only ever returns one thing, right? Either you send a message or you start a timeout or,
Exactly.
that's it. Yeah.
Because like it's you can't in one step send two messages, because this is
Right.
kind of double voting.
Yeah.
Same
Yeah,
effect.
you'll get it. You'll get it when it comes back in on the input side, right? So if you're the proposer and so the return message is a proposal, then the executor will then have the whole, put together a proposal, and then it'll recall the consensus function with the event proposal, having the whole proposal being passed in.
So there would be. Well, so
For me, more or less, the question is because there are quite a few changes we'll make now to the code, and so also I mean tests would need to be adapted, and so just regarding this proposal, if we are kind of close to have agreement that this is something which makes sense, then what is timeline, when we want to try implementing this? Because for what we are trying to do right now, this aligning spec and making these changes, this would be really beneficial. But now the question is, do we want to do it now, or because of launch, or we want to postpone it? This is yeah.
Yeah, there's it's, I guess I don't have visibility into all the other issues that we need to build for Tendermint, but just over the weekend or before, I was also thinking about the event system, the evidence system, and how much work there still needs to be done there. I can write an ADR about it. It seems like if it might be good to consider this a post-launch refactor. Just proposing that. It seems like that would get us to launch sooner. I do also understand that this might be a good way to go about doing it. Refactoring consensus engine. So, and if this shape of the consensus function works, then yeah, I think even making it pure would be fine. My concern there was, keeping the both set and part set inside of the state. But if the design is intentionally leaving that out, and it seems like that might work, then yeah, the pureness is okay too. I think it's a matter of pros and cons with regards to our timing to launch and our confidence of its correctness.
Yeah, I think we have a number of other priorities we need to be focusing on in the short term.
Mm-hmm.
There may be small steps we can take towards this, and maybe we can start looking out for those or identifying some of those, but this probably isn't something we want to dive into just yet.
Yeah. For me, this it makes sense, and so it would be good if we can kind of wrap up around this ADR and have kind of proposal ready, and then when we have a bandwidth, we can go ahead. And so right now we'll use hopefully we can do a minor improvement, like for example improve the test functions, the current one we have, so that it doesn't hang when there is some issue, and maybe if it can be a bit simplified so it is more to the point. But I think it's fine to do like this.
Cool.
You guys.
Thanks, everyone. Thanks, Zarko.
Yeah, everyone. Thank you.
See you online.